Take a long, slow breath in, allowing your body to settle deeply into the quiet comfort of your resting place. Release the air softly, letting go of the day as we embark on a journey far beyond our own sky. Tonight, we are traveling roughly 1.2 billion kilometers away from Earth, drifting gently toward the serene golden glow of Titan. What is fascinating is that Titan, Saturn's largest moon, is the only moon in our entire solar system with a dense, substantial atmosphere. As you imagine descending through its quiet clouds and stepping onto its surface, the first thing you notice is the thick, amber-colored air. This atmosphere is composed of about 95% nitrogen and roughly 5% methane, creating a permanent, deeply calming golden haze that wraps securely around the entire world. Here, in the sunlight filtering through this thick atmosphere, is only 1/1000th as bright as a sunny day on Earth. It creates a perpetual, soft twilight, a soothing, eternal evening that rests gently on your eyes. To be here is to exist in a deeply peaceful state of suspension. The temperature on Titan's surface is a steady, preserving -290 degrees Fahrenheit, or -179 degrees Celsius. In this profound, quiet cold, ordinary water behaves entirely differently. It turns into ice so incredibly solid that it forms the very bedrock beneath your feet. The ground you walk upon is made of water ice that is frozen as hard and unyielding as granite is on Earth. If you were standing here, the physical sensation would be profoundly comforting. The atmospheric pressure at the surface of Titan is about 1.45 times that of Earth at sea level. It feels just like a gentle weighted blanket, pressing evenly and smoothly against your entire body. Combined with Titan's gravity, which is a mere 14% of Earth's, you would feel incredibly light. You would be almost buoyant, floating slightly with each step, yet held safely and securely in place by the thick, heavy air. High up in the stratosphere above you, ultraviolet light from the distant sun slowly breaks down methane molecules. This delicate, silent reaction forms complex organic compounds called tholins. These tholins drift downward in a microscopic, unending snow, dusting the water ice bedrock in soft, reddish-brown hues. When the Huygens probe safely touched down on Titan in the year 2005, becoming the first and only spacecraft to land in the outer solar system, its sensors revealed exactly what this ground feels like. The surface texture felt like soft, wet clay or damp sand, giving just slightly beneath the probe's weight. Imagine the sensation of stepping onto this cool, soft, yielding surface, surrounded by the quiet hum of a completely alien environment. Here is something most people do not know. Titan is the only celestial body in the solar system, other than Earth, known to have stable bodies of liquid resting upon its surface. However, because of the extreme cold, it is not water that flows here. The liquid that shapes this quiet world is a pristine mixture of liquid methane and liquid ethane. Titan possesses a complete, active hydrological cycle, exactly like Earth's water cycle, but based entirely on these flowing hydrocarbons. There is slow evaporation, gentle cloud formation, soft precipitation, and steady river flow, all moving together in a rhythmic, ancient harmony. Imagine feeling the rain on this world. Because of the low gravity and the incredibly dense atmosphere, a methane raindrop on Titan behaves completely differently than water does on Earth. It swells and grows nearly twice as large, reaching up to 9 millimeters across. And when it falls, it does not plummet. It drifts. A methane raindrop descends at a gentle rate of merely 1.6 meters per second, falling as slowly and softly as a winter snowflake. If you looked up into the amber sky, you could watch a single, shimmering bead of clear liquid slowly trace its way down for several minutes before it finally, silently, touches your skin. Time itself feels stretched out here. Because Titan orbits Saturn, and Saturn takes 29.5 Earth years to complete a single journey around the Sun, the seasons on Titan are incredibly long. A single season, whether it be spring, summer, autumn, or winter, lasts for more than 7.5 Earth years. Everything happens at a deeply restful, unhurried pace. These slow, hypnotic methane rains gather into gentle streams, carving smooth, meandering channels into the hard water ice bedrock. They flow steadily toward the vast, silent basins located primarily near Titan's North Pole. As we follow the path of these quiet rivers, the landscape opens up, and we arrive at the majestic shores of Kraken Mare. Kraken Mare is the largest body of liquid on Titan. It is a massive, incredibly serene methane sea that covers approximately 400,000 square kilometers of the Moon's surface. To put that magnificent scale into perspective, Kraken Mare is significantly larger than the entire Caspian Sea on Earth. It stretches out toward the horizon, blending seamlessly into the orange twilight. Standing at the shore, the visual experience is unlike anything on our home planet, because the extreme cold naturally prevents any suspended particulates or microscopic life from clouding the fluid. The liquid methane and ethane is absolutely perfectly clear. It is as transparent as liquid glass. You can look straight down through the perfectly still surface and clearly see the smooth, frozen contours of the water ice seabed sloping gently away into the calm, amber depths. Just a short distance to the north lies Ligeia Mare, another vast and tranquil expanse. Ligeia Mare contains an astonishing volume of liquid, roughly 9,000 cubic kilometers of pure liquid methane. That is enough fluid to fill Lake Michigan 3 times over. Yet, despite its massive, sprawling size, its surface is incredibly tranquil. The heavy, dense air and the gentle pull of Titan's low gravity mean that waves on these alien seas are exceptionally small and sluggish. Radar measurements taken by the Cassini spacecraft, which carefully mapped these hidden lakes between 2004 and 2017, reveal that the tallest waves on Ligeia Mare reach only about 1 centimeter, or less than half an inch, in height. They do not crash, and they do not roar. They ripple slowly, spreading outward with the thick, smooth consistency of syrup, producing a soft, rhythmic, mesmerizing lapping sound against the frozen shore. The liquid in these northern seas is a seamless, harmonious mixture. Liquid ethane is slightly denser than liquid methane, and as the two flow together into deep basins like Mare, Titan's third largest sea, which measures roughly 380 kilometers across, they blend perfectly. The quiet stillness of these profound lakes is occasionally graced by a gentle phenomenon that scientists affectionately call magic islands. These magic islands are transient, ephemeral features that slowly appear on the smooth surface of the lakes, linger gently in the golden twilight, and then quietly dissipate. Researchers have found that these are actually vast patches of nitrogen gas bubbles. The cold liquid methane naturally absorbs nitrogen from the thick atmosphere resting heavily above it. As subtle, slow shifts in atmospheric pressure or temperature occur, with the changing of the long seasons, the nitrogen is gently released. It unspools and rises to the surface in millions of tiny, effervescent bubbles. Imagine standing on the quiet shoreline, watching this delicate process unfold. A wide, shimmering patch of effervescence blossoms on the glassy surface, fizzing softly in the quiet air. It catches the dim amber light for a few peaceful moments before fading back into the perfect mirror-like stillness of the lake. To be here is to witness nature operating on a totally different, infinitely patient timescale. In the extreme cold naturally slows the movement of molecules, slowing the wind, slowing the water, and creating a world defined by its quiet, unhurried grace. Every texture, from the damp, clay-like tholins underfoot, to the hard, granite-like ice, to the slow-motion drops of rain, invites you into a state of profound, peaceful stillness. You are standing on the edge of the solar system, wrapped in a weighted blanket of golden nitrogen, watching glass-clear methane lap gently against an ancient frozen shore. Stepping back from the perfectly still, glass-like edge of Kraken Mare, we can pause to trace the long, quiet journey of human understanding that eventually led us to this distant shoreline. For most of our history, this world was completely hidden, an invisible wanderer in the deep dark. 1. Scientists discovered this moon in the year 1655, when a patient Dutch astronomer named Christian Huygens pointed a custom-built 50-power refracting telescope toward the rings of Saturn. Through the thick glass lenses he had carefully ground and polished by hand with his brother, Huygens spotted a tiny, steady point of light orbiting the gas giant. For nearly 2 centuries, it was simply known as the Hygenian satellite. It was not until 1847 that the English astronomer John Herschel officially named it Titan, drawing upon the ancient mythological siblings of Cronus, the Greek equivalent of Saturn. Consider how long this world kept its truest nature a secret. We did not even know Titan possessed an atmosphere until 1944. That year, the astronomer Gerard Kuiper attached a spectroscope to the McDonald Observatory telescope in Texas. By reading the specific wavelengths of light reflecting off the moon, Kuiper identified distinct absorption bands. These missing slices of light proved, without a doubt, the presence of a thick envelope of methane gas. Even then, the surface remained entirely shrouded in mystery. When the Voyager 1 spacecraft performed a close flyby in 1980, hoping to photograph the landscape, its cameras could not pierce the heavy, photochemical smog. To the optical lenses of Voyager, Titan looked like a smooth, featureless orange billiard ball. The opaque atmosphere acted as a perfectly sealed curtain. Picture this. For decades, researchers could only dream of what might lie beneath that golden veil, and they theorized the existence of liquid oceans, but they needed a completely different way of seeing. That vision finally arrived in 2004, when the Cassini spacecraft slipped gracefully into orbit around Saturn. Cassini was equipped with a specialized Ku-band radar system, emitting microwave pulses at a frequency of 13.78 gigahertz. The radar effortlessly sliced through the amber haze. When the signals bounced back from Titan's surface and were translated into images on Earth, humanity finally saw the intricate, alien geography. Over its 13-year mission, Cassini mapped approximately 1.6 million square kilometers of liquid bodies resting silently across this world. At this very moment, we can understand how incredibly complex this environment truly is. Notice how the lakes and seas are not distributed evenly across the moon. The vast majority of liquid, including the sprawling Kraken Mare, is concentrated almost entirely near the North Pole. For a long time, this severe asymmetry puzzled astronomers. The answer, it turns out, lies in the elegant slow-motion orbital mechanics known as Kroll-Milankovitch cycles. Because Saturn traces an elliptical path around the Sun, Titan's seasons are asymmetrical. During the northern summer, Titan is further from the Sun, making the season noticeably longer than the southern summer. Over the course of tens of thousands of years, this slight imbalance creates an atmospheric methane pump. You can think of Titan's climate system as a grand planetary scale heart, beating once every 45,000 Earth years. With each long, slow contraction, it steadily evaporates liquid from the southern hemisphere, carries it through the upper atmosphere as vapor, and deposits it as quiet rain in the north. Deep within the southern hemisphere, there is only one major body of liquid remaining, an isolated feature named Ontario Lacus. Measuring 235 kilometers in length, Ontario Lacus behaves quite differently from the deep northern seas. Radar mapping shows that its shorelines frequently recede and advance, leaving behind a smooth, saturated rim. In this way, it functions much like an ephemeral salt pan or a tidal mudflat on Earth, shrinking and swelling with the incredibly long passage of the Titan seasons. What's happening now along the edges of these ancient lakes is a process of slow, continuous geological sculpting. The shorelines of Titan feature incredibly steep, dramatic cliffs. Many of these liquid basins are surrounded by elevated ramparts that rise hundreds of meters straight up into the dense nitrogen air. Geologists classify this as a karst terrain. On Earth, karst landscapes form when slightly acidic groundwater slowly dissolves away soft limestone, creating deep sinkholes and towering cliffs. On Titan, the intensely cold liquid methane performs exactly the same patient work. It slowly dissolves the solid organic compounds that coat the water ice bedrock, carving out deep, steep-sided bowls that subsequently fill with falling rain. Where the rivers meet the seas, the topography reveals intricate branching patterns. The shorelines here are heavily indented with rias, which are essentially drowned river valleys. Few have ever seen an aerial view of the Chesapeake Bay on Earth, with its sprawling, branching inlets flooded by rising sea levels. You perfectly understand the shape of Titan's northern coastlines. The methane rivers carved deep canyons into the ice long ago, and as the northern lakes filled, the liquid quietly backed up into those riverbeds, creating absolutely still, winding fjords. Along these silent shores, the chemistry creates materials entirely unknown on our home planet. As the liquid slowly interacts with the atmosphere and the bedrock, unique structures called cryominerals begin to form. In laboratories attempting to replicate Titan's negative 290-degree Fahrenheit surface, scientists discovered that benzene and ethane molecules bond together to create intricate co-crystals. If you were standing on the shoreline, stepping across this frozen sand, you would be walking on microscopic, perfectly arranged lattices of purely organic chemistry. And though the air is unbreathable and freezing, if you could somehow take off a helmet and smell this environment, the presence of benzene and related hydrocarbons would carry a remarkably sweet, sharp, aromatic scent. Among these complex chemicals is a steady trace of liquid acetylene, gently washing into the deep basins with the rainfall. This is particularly interesting to astrobiologists, as acetylene holds a significant amount of stored chemical energy. Researchers have calculated that hypothetical, exotic, methanogenic life forms, microscopic organisms adapted to the profound cold, could theoretically consume this acetylene and hydrogen, exhaling methane in return. The lakes are not just bodies of fluid. They are immense, undisturbed chemical crucibles, perfectly preserved in the deep freeze of the outer solar system. Beneath the solid water ice surface, the hydrology continues in absolute darkness. Researchers mapping the fluid levels of adjacent lakes noted that they share identical surface elevations, responding to the seasonal changes in perfect unison. This alignment indicates the presence of an alkanophore, an underground, porous network completely saturated with liquid hydrocarbons. Just as aquifers on Earth invisibly connect springs and lakes through subterranean water pressure, this alien alkanover links Titan's basins beneath the icy crust, allowing the liquid methane to slowly equalize across hundreds of miles. The interplay between the liquid surface and the sky is a delicate, yet continuous balance. While the methane gas in the atmosphere acts as a powerful greenhouse agent, attempting to trap the faint warmth of the distant sun, the thick organic smog high above creates an opposing anti-greenhouse effect. The Tholen haze reflects incoming solar radiation back out into space so efficiently that it actually lowers Titan's surface temperature by 9 degrees Kelvin. The atmosphere is a protective, cooling blanket, ensuring the precious liquid never boils away into the vacuum of space. In the year 2009, as the Northern Hemisphere finally tilted toward the sun to begin its long, multi-year spring, the Cassini spacecraft captured something breathtaking. Flying high above the cloud tops, its infrared spectrometer detected a brilliant, sudden flash of light. It was a specular reflection, a perfect sun glint bouncing directly off the mirror-smooth surface of Jingpo Lacus, a smaller lake nestled near the Great Northern Seas. It was the first time humanity had ever seen sunlight reflecting off a liquid surface on another world. That solitary beam of light, traveling over 1 billion kilometers from the sun, piercing the thick amber smog, striking the clear, glassy methane, and rebounding into the lens of a robotic explorer, stands as a quiet testament to the enduring beauty of our solar system. The environment here is a masterpiece of slow planetary patience, where crystalline chemistry and gentle rains shape the land over thousands of unhurried years. Stepping slightly closer to the shoreline of these tranquil northern seas, we encounter the physical reality of liquid methane and ethane. Consider the very substance of this alien fluid. If you were to scoop it up in your hands, it would not behave like the water flowing from your kitchen tap. Liquid methane at these extreme temperatures has a density of about 422 kilograms per cubic meter. That is roughly half the density of ordinary water. Instead, its consistency closely resembles rubbing alcohol or a very thin paint solvent you might keep stored on a garage shelf. Picture this. If you constructed a small wooden boat and set it gently onto the surface of Ligeia Mare, it would sit much lower in the fluid than it would on a terrestrial pond. However, if you picked up an oar and began to paddle, the resistance against the wood would be incredibly minimal. You would glide across the perfectly clear, glassy surface with almost no physical effort, no sliding smoothly through a substance that offers very little drag. Every movement would feel effortless, light, and completely unburdened. Deep within these enormous basins, the liquids do not always exist in a perfectly uniform blend. Imagine a simple bottle of vinaigrette dressing resting undisturbed in a kitchen pantry where the heavy oil and the lighter vinegar naturally settle into distinct stacked layers. Scientists discovered that a remarkably similar kind of stratification occurs within the hidden depths of Titan's lakes. Because liquid ethane is slightly heavier than liquid methane, and because the faint sunlight barely warms the cold depths, subtle temperature shifts cause the fluids to cleanly separate. At varying depths, distinct layers form, creating sharp, invisible boundaries, known in oceanography as haloclines. If you dropped a small pebble from your boat, you could watch it sink through the transparent top layer of methane, pause for a microscopic fraction of a second as it hit the denser ethane boundary, and then continue its slow, tumbling, unhurried descent toward the dark water ice bottom. Notice how the edges of these lakes trace distinct, multi-layered lines along the rocky shores. As the long 7.5-year seasons shift, and the liquid very slowly evaporates into the thick nitrogen sky, it leaves behind precise, solid residues. Think of a natural hot spring on Earth, or even a bathtub where hard water has slowly drained away, leaving a visible pale ring around the smooth porcelain. On Titan, these delicate formations are called evaporate deposits. They are composed entirely of solid organic compounds, mostly acetylene and butane, that were previously dissolved evenly within the lake. Planetary geologists have measured these brightly glowing bands stretching for dozens of kilometers around the intricate shorelines. They form a brilliant pale border that starkly contrasts with the dark, damp coast, serving as a quiet chemical memory of exactly where the lake levels once rested during the height of the long wet season. Flowing quietly into Ligeia Mare is an intricate river network known to astronomers as vid flumina. What's happening now within this branching channel is a display of breathtaking geological scale that rivals our most famous terrestrial landmarks. Radar altimetry reveals that the canyons carved by the gentle flow of vid flumina are astonishingly deep. Their sheer walls plunge down nearly 570 meters, or 1,870 feet. If you were to stand at the top of these cliffs and look down, the vertiginous drop would be comparable to peering over the edge of the Black Canyon of the Gunnison in Colorado. Yet, unlike a terrestrial canyon that holds a shallow, rushing river at its bottom, these massive gorges on Titan are completely flooded. The liquid methane reaches all the way up to the very brim, creating incredibly deep, perfectly still slot canyons that wind silently and peacefully through the frozen crust. Imagine the sounds that might echo across these flooded canyons. The dense, incredibly cold nitrogen air changes the fundamental physics of how sound waves travel. In Earth's atmosphere, sound moves at about 343 meters per second. But on Titan, the extreme chill and the heavy atmospheric pressure lower the speed of sound to roughly 194 meters per second. If you could safely stand on the shore and clap your hands, the noise would take noticeably longer to return to your ears as a distant echo. Furthermore, the thick air easily absorbs high-frequency sound waves. The result is an environment that naturally muffles sharp, piercing noises. The entire acoustic experience would be deeply muted and low-pitched. It sounds remarkably similar to how the world feels on a quiet morning when a heavy, thick layer of fresh snow has just blanketed your neighborhood. Every noise feels close, soft, and perfectly insulated. Moving far away from the damp northern poles, toward the moon's equator, the landscape transitions into something resembling a sprawling, endless desert. However, the organic sand here shares absolutely no relation to the silica grains found on a sunny terrestrial beach. The equatorial dunes of Titan are massive, stretching uninterrupted for thousands of kilometers and towering up to 100 meters high. They are composed of dark, complex organic particulates formed high in the amber atmosphere. To understand their unique texture, you should not imagine ordinary sand, but rather something closely resembling fine, dry coffee grounds or tiny, dark beads of polystyrene plastic. These grains carry a strong electrostatic charge. Just as a balloon rubbed against a sweater sticks firmly to a wall through static electricity, these organic grains cling together tightly in the low gravity. When the gentle winds eventually carry these charged particles northward, they occasionally settle onto the surfaces of the methane lakes. They float briefly on the surface tension before slowly, peacefully sinking to form a soft, dark, organic sludge on the quiet seabed. At this very moment, this gentle, persistent movement of wind, liquid, and falling particles acts as a massive planetary smoothing mechanism. Across the entire surface of Titan, a world roughly the size of the planet Mercury, there are only about 60 confirmed impact craters. This is an extraordinarily low number for a moon in the outer solar system, where celestial bodies are typically heavily pockmarked by ancient asteroid strikes. You can compare this process to a baker carefully dragging a flat metal spatula over a freshly frosted cake, instantly filling in and erasing any dents or imperfections. The continuous, slow-motion rains, the dissolving power of the lakes, and the drifting organic sands work perfectly together to constantly bury and wash away the violent scars of the past. It is an environment that perpetually renews itself, replacing chaos with smooth, undisturbed serenity. Consider just how delicate this entire liquid ecosystem truly is. The liquid methane and ethane exist in a highly precarious state, teetering gracefully on a very fine thermal edge. Pure methane freezes into a solid at negative 182 degrees Celsius, while ethane freezes at negative 183 degrees. The average surface temperature resting softly over these lakes hovers exactly at negative 179 degrees Celsius. The massive northern seas are a mere 3 to 4 degrees away from freezing entirely solid. Imagine a glass of crushed ice and sweet syrup that has been left outside on a bitterly cold winter day, hovering right at the precise tipping point where a single drop in temperature would turn it into an unyielding block of ice. Yet, the thick nitrogen blanket above them holds the faint solar heat just perfectly enough, year after long, quiet year, maintaining the balance. This gentle atmospheric hug ensures that the lakes remain fluid, allowing the sluggish, heavy waves to continue lapping softly against the eternal frozen shore in a rhythm older than human history. Reflect on the profound quiet of this distant world and how its ancient, unhurried processes might mirror the quiet rhythms within your own life. When we look at the serene, glassy surface of the methane lakes, we are not just observing an alien landscape. Shuts. We are gazing into a grand planetary-scale mirror that reflects the deepest origins of life itself. To understand this connection, think about the fundamental building blocks of your own body as you rest here. Every single cell within you is protected by a delicate, flexible membrane, a microscopic boundary that separates the quiet, ordered life inside the cell from the environment outside. On Earth, these membranes are made of lipids, which perfectly organize themselves in warm, liquid water. For a long time, scientists believed such delicate biological structures could only exist in terrestrial oceans. Yet, in the year 2017, astronomers using the Atacama Large Millimeter Array in Chile detected massive quantities of a molecule called vinyl cyanide high in Titan's atmosphere. What researchers quickly realized is that vinyl cyanide is the perfect architectural material for an environment completely devoid of liquid water. In the intensely cold liquid methane of Titan's lakes, these molecules can naturally link together to form incredibly resilient, flexible spheres known as azotosomes. These theoretical azotosomes function exactly like the membranes of your own living cells, but they are uniquely adapted to remain entirely supple and fluid at a preserving negative 290 degrees Fahrenheit. It is a deeply comforting thought. Even in the freezing dark reaches of the outer solar system, the fundamental urge of chemistry is to organize, to protect, and to quietly build the foundations of potential life. Imagine the sensation of actually being present on this world, unburdened by the heavy gravity of our home planet. Because the nitrogen atmosphere is so profoundly dense, and the gravitational pull is merely 14% of Earth's, the physical rules of movement change entirely. The atmosphere at the surface is so incredibly thick that if you were to attach a pair of artificial fabric wings to your arms, you could generate enough lift to fly simply by relying on your own muscle power. The average human resting energy output, roughly 100 watts, would be more than sufficient to keep you airborne. You would not need an engine. You could simply step off one of the high, icy cliffs overlooking Kraken Mare, gently press your arms downward against the heavy, supportive air, and glide. Think of those peaceful, recurring dreams where you suddenly find you can float above the ground with no effort at all. On Titan, that gentle floating dream is a physical reality. You could soar silently over the mirror-smooth lakes, feeling the cool, thick atmosphere rushing softly past you, entirely weightless and completely free. Beneath your imagined flight, hidden deep below the solid water ice crust, lies an even more astounding reality. Titan is not frozen solid all the way through. Roughly 50 to 80 kilometers below the dark organic dunes and the quiet methane shores, there exists a massive global subterranean ocean of liquid water. This hidden internal sea is kept warm and liquid by the immense rhythmic force of tidal heating. Observe how this hidden mechanism works. Titan takes exactly 15.9 Earth days to complete a single, elegant orbit around Saturn. Because it is tidally locked, the same side of the moon always faces the giant ringed planet, much like our own moon faces Earth. However, Saturn's immense gravitational pull constantly tugs and releases the moon's interior, creating a deep, resonant friction. This slow planetary flexing generates enough internal heat to maintain a sprawling, pitch-black ocean composed of liquid water mixed with a natural antifreeze of ammonia. Think of a beautifully crafted nesting doll where the outer painted shell can spin effortlessly, completely detached from the solid wooden core resting within. Data collected from the Cassini mission revealed that Titan's icy outer crust is entirely decoupled from its rocky interior. The heavy frozen surface, along with all its methane rivers, evaporate shores, and silent lakes, actually rotates at a slightly different speed than the deep core beneath it, sliding smoothly over that hidden, lubricating ocean. As you lie resting, feeling your own steady pulse, you can imagine the slow, rhythmic heartbeat of this moon, flexing and warming its secret, inner sea in perfect time with its celestial orbit. From a wider perspective, human curiosity is naturally drawn to this peaceful, complex environment. In the year 2028, a new ambassador from Earth is scheduled to begin its quiet journey here. The Dragonfly mission is an extraordinary piece of engineering, a nuclear-powered dual quadcopter designed to softly explore this alien sky. Weighing approximately 450 kilograms, this gentle robotic explorer will arrive in the mid-2030s. Dragonfly will not use wheels. Instead, it will utilize 8 spinning rotors to fly from location to location, cruising through the thick nitrogen haze at a steady, unhurried speed of about 10 meters per second. It will hop gracefully across the equatorial dunes, carefully sampling the ancient organic sands before flying toward its ultimate destination, Selk Crater. Selk Crater is a massive 90-kilometer-wide depression where an ancient impact once generated enough heat to melt the water ice bedrock. For a brief geological moment, liquid water mixed freely with the complex organic tholins raining down from the sky. by sending Dragonfly to gently touch down in this crater. We are attempting to read a chemical history book, looking for the very same prebiotic reactions that eventually led to our own existence. There is a profound, deeply reassuring balance to how this world maintains itself. The solar ultraviolet light that creates the beautiful protective amber smog also actively destroys methane molecules. Scientists calculate that without a way to replenish the atmosphere, all of Titan's methane would be permanently depleted over a timescale of 10 to 30 million years. Yet, the lakes are still here, full and perfectly serene. This means the moon must be slowly, continually breathing new life into its own sky. Researchers studying the topography discovered massive features that point to a fascinating internal process. Towering above the icy plains is Doom Mons, an enormous cryovolcano standing roughly 1,500 meters high. Right beside it lies a deep, plunging caldera known as Sotra Patera. Instead of erupting red-hot molten rock like terrestrial volcanoes, these quiet mountains occasionally release soft, flowing rivers of cryomagma. This frigid lava is a slushy mixture of water, ammonia, and methanol, welling up from the deep subsurface ocean and gently releasing fresh methane gas back into the dense air. It is a slow, self-sustaining cycle of renewal, ensuring the heavy atmosphere never vanishes and the tranquil lakes never run dry. To comprehend the scale of this quiet abundance, compare it to the energy stored within our own planet. Planetary geologists estimate that Titan contains hundreds of times more liquid hydrocarbons resting in its surface lakes than all the known oil and natural gas reserves combined on Earth. It is an entire world coated in potential energy, perfectly preserved in the pristine cold, far away from the chaotic warmth of the inner solar system. It takes roughly 80 minutes for a single photon of sunlight to travel the immense, silent distance from our sun to the thick amber clouds of Titan. By the time that light finally filters through the heavy nitrogen, touches the mirror-smooth surface of the methane seas, and illuminates the frost-covered shores, it is impossibly soft and gentle. Everything here is part of a magnificent slow-motion dance. Even the moon's relationship with its parent planet is slowly evolving. Through precise measurements, astronomers found that Titan's orbit is gradually expanding, moving away from Saturn at a tiny, imperceptible rate of 11 centimeters per year. It is a gentle, natural drifting, a widening of the circle over millions of years, imperfectly, completely harmless, and entirely serene. As you listen and rest, let the quiet, enduring stability of this ancient moon remind you that nature operates on timescales of incredible patience, where every element perfectly supports the whole, and there is absolutely no need to rush. Shifting our focus to the very air that blankets this tranquil, frosted landscape, we can delve into the elegant mechanics of why Titan looks and feels exactly the way it does. The atmosphere resting heavily over the methane lakes is not merely a passive curtain of gas. It is a highly active, deeply complex chemical engine. By carefully measuring the gravitational pull and the pressure gradients, planetary scientists determined that Titan's atmospheric mass is actually 1.19 times greater than the entire atmospheric mass of Earth. This is an astounding reality for a moon that is considerably smaller than our home planet. Delving into the physics of this thick air reveals the precise reason behind the perpetual golden twilight. High in the stratosphere, the complex organic aerosol particles, known as tholins, are incredibly fine. They measure between 0.1 and 1 micrometer in diameter. These microscopic suspended grains are perfectly sized to absorb the blue wavelengths of incoming solar radiation, while allowing the longer red and orange wavelengths to softly scatter downward. To comprehend the visual experience of standing on the shoreline, you might compare it to gazing outward from the inside of a massive glass jar filled with pure, thick, unpasteurized honey. The intense glare of the distant sun is entirely neutralized. In fact, the dense stratospheric haze naturally blocks 90% of the incident sunlight from ever reaching the lower atmosphere. By the time the scattered photons finally touch the glassy surface of the lakes, the surface illumination is reduced to a mere 0.1% of Earth's daytime brightness. Everything is cast in a deeply soothing, monochromatic amber glow, completely eliminating any harsh shadows or bright reflections. Visualizing the high-altitude weather patterns brings another layer of quiet wonder to this environment. During the extended polar winter, as the northern hemisphere slips into the long, multi-year shadow of Saturn, the upper atmosphere cools to profoundly low temperatures. This extreme chilling causes rare, exotic gases to quietly condense into massive stratospheric clouds. Infrared spectrometers have detected vast, high-altitude banks of hydrogen cyanide ice, accompanied by shimmering layers of frozen cyanoacetylene. These are not fluffy whitewater vapor clouds like we see at home, but rather thin, delicate crystalline veils that drift silently in the upper stratosphere, slowly painting the dark polar sky in invisible chemical strokes. Closer to the ground, where the heavy nitrogen rests against the damp organic crust, a different atmospheric phenomenon takes shape. In the low-lying valleys and directly over the liquid basins, the environment frequently reaches 100% relative humidity for methane. When the temperature drops just a fraction of a degree, thick, slow-moving methane ground fog softly materializes. The individual droplets of liquid methane within this fog are exceptionally tiny, measuring approximately 10 micrometers across. Because of the low gravity and the dense air, this fog does not quickly dissipate or blow away. It settles heavily into the depressions of the land, clinging gently to the contours of the ice bedrock, creating a hushed, mist-shrouded landscape where the horizon completely dissolves into the soft, golden air. An intriguing aspect of this environment is the sensory tapestry it would present to the human nose, if one were somehow able to safely inhale. We know that hydrogen cyanide permeates the lower atmosphere in trace amounts. On Earth, this specific compound produces a very distinct, sharp aroma, remarkably similar to the scent of crushed bitter almonds, mingled with the sweet, the aromatic presence of benzene. We explored earlier, the cold air resting over these lakes possesses a surprisingly rich, complex olfactory signature. It is a quiet, frozen bouquet of organic chemistry, preserved perfectly in the deep cold. The physical sensation of this cold is also uniquely shaped by the thick air. The dense nitrogen atmosphere naturally possesses a very high thermal conductivity at these extraordinarily low temperatures. This means that if a warm object were introduced to this environment, the heavy, frigid air would pull the heat away incredibly rapidly. The cold here is not a biting, windy chill, but a deep, enveloping, absolute temperature that instantly equalizes anything it touches. It is a profoundly stabilizing force, ensuring the water ice remains as solid as terrestrial granite and the methane stays perfectly fluid. Moving away from the smooth, sandy dunes, planetary radar has mapped highly complex geological formations known as labyrinth terrains. The most prominent of these is Pulvani labyrinthus. Here, massive elevated plateaus are deeply intersected by a sprawling, intricate network of narrow, winding valleys. The mechanics behind this landscape are a slow-motion marvel of chemistry. The bedrock in these specific regions contains high amounts of soluble organic compounds. Over millions of years, the gentle, steady rains of liquid methane act as a subtle solvent. The rainfall slowly washes away the soluble carbon materials, leaving behind a perfectly sculpted maze of insoluble water ice ridges. It is an environment carved entirely by the patient, unhurried dissolving power of the organic rains. Direct your focus back toward the massive expanse of Kraken Mare. Along the eastern edge of this great sea, there is a narrow natural bottleneck connecting two massive basins of liquid. Astronomers named this feature Treta Fretum, which translates elegantly to the throat of Kraken. This strait measures roughly 17 kilometers across at its narrowest point. As the moon orbits, the massive gravitational presence of Saturn gently pulls at the liquid methane in the northern hemisphere. This gentle tug creates genuine tidal cycles on a world entirely devoid of water oceans. The liquid flows smoothly through the throat of Kraken, creating steady, rhythmic tidal currents. Oceanographic models based on radar data suggest that the liquid channels through this strait at a velocity of approximately 0.5 meters per second. This is a calm, walking pace. You can picture the perfectly clear liquid methane slowly, deliberately sloshing back and forth through the narrow icy corridor, a quiet planetary breathing that reverses direction with the endlessly long passage of the Titan Day. Where these currents wash against the shore, they shape the physical texture of the land. When the Huygens probe safely settled onto the damp ground, its cameras transmitted high-resolution images of the immediate surroundings. Scattered all across the landing site were smooth, perfectly rounded stones. Scientific analysis revealed these pebbles measure exactly 10 to 15 centimeters in diameter. However, they are not made of silicate rock. They are pure chunks of frozen water ice. The mechanics that created their shape is known as fluvial abrasion. Over countless eons, these small blocks of ice were gently tumbled and rolled along the bottoms of the methane rivers. Because they weigh so little in the 14% gravity, they did not shatter against one another. Instead, they bounced softly, gently grinding their rough edges away over millions of years of patient transit. The result is a floodplain covered in perfectly polished, smooth ice cobbles, resting quietly in the damp, dark Tholen clay. What makes the preservation of this entire delicate system possible is its precise location in the solar system. Titan lacks a strong intrinsic magnetic field of its own. On many worlds, the absence of a magnetic shield would allow the harsh solar wind to slowly strip away a thick atmosphere, blowing the precious gases out into the void of space. However, Titan follows a perfectly calibrated path that keeps it shielded. For approximately 95% of its orbital journey, this moon resides safely nestled inside Saturn's massive magnetosphere. The giant ringed planet acts as a colossal, invisible umbrella. As Saturn's rotating plasma sheet sweeps completely over the moon, it safely deflects the damaging solar wind. Furthermore, this gentle interaction with Saturn's magnetic field provides the exact amount of energy required to ionize the nitrogen in Titan's upper atmosphere, sparking the initial chemical reactions that slowly drift down as the amber haze. Every single element of this environment, the shielding magnetic field, the high-altitude ice clouds, the dense fog, the labyrinthine valleys, and the polished ice pebbles, exists in a state of continuous, quiet cooperation. The processes here do not fight against one another. They blend and balance over timescales that dwarf human comprehension. It is a perfectly calibrated system of cold, quiet stability, maintaining its serene twilight glow as it silently circles the ringed giant in the dark. Observe the precise sequence of how this heavy golden sky physically interacts with the ground below. Everything on this moon occurs through a meticulous, step-by-step progression, completely unbothered by the passing of time. We can trace the slow downward journey of the atmospheric haze to understand the true meaning of patience. It takes an individual Tholen particle, a single microscopic speck of complex organic material formed high in the stratosphere, approximately 1,000 Earth years, to slowly drift all the way down to the water ice bedrock. Generation after generation of human history rises and falls on Earth, while a single silent speck of reddish dust calmly completes its descent through the thick nitrogen air. Follow the journey of how a single drop of liquid is born in this alien environment. The creation of a methane raindrop is a gradual, highly orchestrated event. The first step requires a microscopic seed, typically a tiny frozen crystal of cyanoacetylene, hanging suspended in the cold, lower troposphere. Over the course of several Earth months, invisible methane vapor begins to slowly condense around this specific nucleus. Micron by micron, the liquid layer steadily thickens. It gathers mass in absolute silence, hanging weightlessly in the dense fog. Only after this months-long accumulation crosses a precise threshold of critical mass does the droplet finally begin its incredibly slow parachuting descent toward the damp organic dunes. Witness how the atmosphere moves in completely distinct, independent layers. High above the cloud tops, the sky engages in a mechanism called superrotation. The high-altitude winds are remarkably swift, rushing completely around the entire circumference of the moon in a mere 24 Earth hours, even though the solid, icy body of Titan takes nearly 16 days to complete one full rotation. Yet, as you descend step by step through the thickening atmospheric density, the kinetic energy is systematically absorbed and dampened. By the time you reach the shoreline of Kraken Mare, the surface wind speed has dropped to a completely stagnant 0.5 meters per second. The chaotic energy of the upper atmosphere is meticulously filtered out, leaving the surface layer in a state of absolute heavy tranquility. As the gentle methane rains finally reach the ground, they initiate a quiet, upward journey through the soil. The sandy water ice regolith here is highly porous. When the liquid methane touches this dry organic sand, it activates a powerful process of capillary action. Step by step, the liquid actively wicks upward against the gentle pull of gravity. It crawls smoothly through the microscopic branching gaps between the frozen sand grains. This continuous, slow-motion wicking mechanism ensures that the solid ground remains permanently damp, drawing fluid from the subterranean water table up to several meters high into the dry crust above. The sprawling basins of liquid possess an extraordinary ability to maintain their own stable temperatures, a scientific property known as thermal inertia. Through the entire length of the 7.5 Earth-year summer, as the faint sun continuously shines upon the northern hemisphere, the deep liquid methane of Ligeia Mare warms by a maximum of only 2 degrees Kelvin. It perfectly resists the change of the seasons, holding on to its preserving freezing temperature with unwavering steadiness. At the very bottom of these silent seas, an invisible structural transformation unfolds, where the liquid methane meets the solid water ice seabed at extreme pressures. Clathrate hydrates begin to form. This is a step-by-step architectural process. The rigid geometric crystal lattice of the cold water ice slowly opens, capturing individual methane gas molecules and physically locking them inside tiny frozen cages. The ice literally swallows the gas, storing massive quantities of methane safely away within the bedrock in a perfectly ordered, permanent grid. Along the twisting, flooded fjords, the fluid shapes the rock through a method of impossibly slow erosion. The liquid methane gently dissolves the organic compounds, binding the water ice shores, but it does so at a calculated pace of only a few millimeters per Earth year. The gradual undercutting of the sheer ice cliffs is so incredibly subtle that a human observer standing on the shore for an entire lifetime would not notice a single change in the contour of the land. As we turn our attention inward toward the deep interior of the moon, we find a massive rhythmic pulse orchestrating from the core. Saturn's immense gravitational pull initiates a physical deformation of the entire world. Step by step, as Titan travels its slightly elliptical orbit, this tidal force causes the entire solid water ice crust to bulge outward by a full 10 meters. As the moon completes its 16-day orbital path, this 10-meter crustal bulge slowly rises and gently subsides. It is a planetary deep breath, a continuous, slow-motion kneading of the hidden subterranean ocean resting beneath the ice. This deep internal flexing drives a methodical process of outgassing. When the Huygens probe analyzed the atmospheric composition, it detected the specific heavy isotope argon-40. The presence of this noble gas proves a continuous, slow venting sequence from the deep rocky core. Planetary geologists calculate that this steady release represents exactly 25% of the total radiogenic argon naturally produced inside the moon's interior. It slowly bubbles up through the subterranean ocean, slips through the cracks in the thick ice crust, and quietly exhales into the heavy nitrogen sky. Even the immense weather patterns over the poles operate on a timeline of supreme patience. A massive swirling cloud formation, known as the stratospheric vortex hood, rests entirely over the winter pole. As the long seasons shift, this gigantic structure undergoes a step-by-step breakdown. The toxic ice clouds slowly dissipate, the winds naturally calm, and the entire vortex quietly fades away, only to entirely reform over the opposite pole on a strict, cyclical 15 Earth-year schedule. Every single process on this tranquil moon, from the 1,000-year descent of the golden dust to the invisible locking of the ice cages, occurs with absolute unhurried grace. There is no rush. There is no urgency. The environment operates in a state of perfect preservation, suspended safely in the quiet dark of the outer solar system. We can bring our observation to a gentle, comforting halt, allowing the dimming amber light to slowly fade from the mind's eye. The absolute stillness of the methane lakes offers a perfect reflection for your own internal state of rest. Just as the heavy nitrogen atmosphere completely dampens the chaotic winds, absorbing all turbulence before it reaches the ground, your own physical body is now filtering out the noise of the waking day. Notice the slow, rhythmic rising and falling of your own breath, mirroring the gentle 10-meter tidal swell of the moon's icy crust. Each inhalation draws in calm, stable energy. Each exhalation releases the residual tension of the day. The processes within your own biology are beautifully shifting into their nighttime routines. Heart rate slows, adopting a steady, unhurried cadence. The nervous system quiets, lowering its temperature, settling into a state of profound thermal inertia, where nothing can disturb your foundational peace. Give permission for your muscles to sink heavily into the surface beneath you, feeling securely held by gravity, much like the smooth ice cobbles resting perfectly still on the damp organic floodplains. Your cells are beginning their silent, methodical work of clearing cellular fatigue gently flushing away metabolic byproducts, restoring your physical structure layer by layer in the quiet dark. Embrace the heavy, protective stillness wrapping securely around you. The day is entirely complete. There is nothing more that needs to be done. There are no more tasks to accomplish, no more thoughts to actively untangle. Everything is slowing down to its most comfortable restorative baseline. I am safe in this quiet space. My body knows exactly how to enter deep rest. The rhythm of my breathing is slow, steady, and perfectly calm. I release the need to control or guide my thoughts. I allow the natural heavy comfort of sleep to wash over me. Every muscle in my body is loose, heavy, and completely relaxed. The quiet dark is a completely soothing, protective blanket. My mind is incredibly still, reflecting the absolute calm of an undisturbed sea. I give myself completely to the restorative power of rest. I am entirely at peace. My surroundings are safe, quiet, and perfectly still. I welcome the slow, gentle transition into total relaxation. I am comfortably heavy, beautifully supported, and deeply secure. Peace resides in every breath I take. I am ready to surrender to the quiet. Good night.